Hello. We're going to do 9.2 today, transformations of quadratic functions, and this is where we're applying those left 2, up 4, down 3, vertical stretch. We're applying that to quadratic functions. If you remember, our parent quadratic function is just x squared, and that looks, I'm going to just fill this in, maybe. There we go. If I plugged in a 0, I'd get 0. If I plugged in a 1, I'd get 1. If I plugged in a negative 1, I get 1. And 2 would give me 4, etc. So this is what that parent function looks like. You guys are going to get a kick out of my drawings. Yep, can't even make it. To give you a general idea of the quadratic parent function. Now, whenever you add things onto this, like a negative 2, it means it shifts down 2. And we're going to look at those a little bit specifically. I'll try to do tons of examples, and hopefully you get so bored with it you just start skipping through because you're so awesome and you already get all this. We've learned it. We've learned the basics, but we're applying it to just a new concept. Instead of linear or exponential, we're doing quadratic. So, there we go. We'll start with vertical translations. And I'm not going to graph all these. I'll do one or two just to kind of give you an idea of what these look like. But right here, when you have this minus 7 out here without any parentheses, that means you're going to be moving it down 7. Wow, that's looking good. Okay, so my original one, I should just did on this paper. Looks like this. And my new one will be down 7. 1, 2, 3, 4, 5, 6, 7. So it looks just, every point is actually moved down 7. So if I moved every point down 7, this is actually what it would look like. And that's just a way I can graph it without having to plug in numbers. But you can always plug in numbers. When in doubt, whenever you're graphing something, always plug in numbers. It's totally fine. This one here, this plus 1, means you're moving up 1. Okay, so that one's going to look more like in this general area. But I'm not going to draw it all out. This 1c, if you notice, it's kind of in a backwards format. So you have to rewrite it so it says x squared minus 5. Then you can easily see that that's going down 5. Remember, these up downs are pretty easy. We'll move on to horizontal left right next. So the left right is the backwards stuff, but it's the stuff in the parentheses. So if you look at this one here, where you have x minus 3, that means it's going to be moved to the right 3 because it's all wonky and backwards. Okay? So my original one, again, would look something like this. Hey, I think I'm getting better with practice. And this x minus 3 in parentheses squared is moving to the right 3. So it's going to look exactly like this one, the original parent function one, except every point has moved to the right 3. So it looks kind of like that. So for 2b, then, we have an x plus 2, which you can guess means you're moving to the left 2. So same thing as this one, but now it's going to look like this. Remember, the black one is the original parent function. When I combine a couple of these, so these next two examples, I'm combining the vertical shifts and the horizontal shifts. So this one here, it's going to be left 2 and up 3. I'm going to erase some of this, maybe. So I can kind of, wow, that erased my lines too. That's okay. I'm going to do this in red. So if I go left 2 and up 3, if I take every one of these points that I had originally, I go left 2, up 3. Take this one, left 2, up 3. This one, left 2, up 3. This one, left 2, up 3. Left 2, up 3. I have the same thing except moved left 2, up 3. Okay? So, and you can plug in numbers. Do an XY table. You know, you're going to find out that that's exactly what you'll get if you do it right. You know, I put in a 0 and I'm going to get 7 out. My XY table, if I put in 0, 0 plus 2 is 2, 2 squared is 4, 4 plus 3 is 7, 0, 7. Oh, there you go. That's exactly what I have there. So that'll work every time. Let's look at 3B. This one's moving to the right 4 and down 1. Okay. Let's go on to dilations, a little bit more difficult. So if you remember, I'm not going to be drawing all these out, but if you remember the dilations, you can have vertical stretches or compressions, and those are going to be on the outside of your function, okay? So no parentheses involved. And on these ones, if it is a more than 1, it's going to be a stretch, and if it's a fraction or between 0 and 1, it's going to be a compression. So for A here, this is going to be a vertical compression, and you can write by half, but I think at this level we're just saying vertical compression, so you don't have to write that. For B, well, actually, let's skip to 4C. So for C, again, this is on the outside. There's no parentheses, so we know it's vertical. And the fact that it's more than 1, it means it's a stretch. Okay. Let's back her up. So 3x in parentheses. Now this is going to be horizontal, but is it going to be a stretch or a compression? Remember, these ones are backwards because anything horizontal, anything in the parentheses is going to be wonky. So it's kind of the opposite of what you think. So you would think that should be a stretch, but it's not. This is going to be a compression. And likewise, if you go down to 4D, you have a fraction and it's inside the parentheses, so you know it's going to be horizontal, and since it's a fraction, it's going to be a stretch. So, horizontal stretches, horizontal compressions, vertical stretches, and vertical compressions. I have these examples over here because we're combining a bunch of different transformations. And I think it's just good practice to be able to see what these look like. And I would just go from the left to the right and look at the different transformations. So basically, I'm looking to see what has changed from this parent function. Okay? Well, a lot has changed here. I have this 1/3 out front. What do you think that means? Well, it's out front, so it's a vertical stretch or compression, and it's between 0 and 1, so this is going to be a compression. So we have vertical compression. Then we have this -6 in parentheses, so that means it's going to the right 6. And then we have -4 outside tacked on at the end, not inside a parentheses or anything, so that means we're going up or down. This means down 4. Here we have a 5 multiplied inside the parentheses. So we're going to have a horizontal compression. This plus 2 is going to say left 2, and this minus 3 is going to be down 3. Eight x squared plus 9, this 8 in front is going to be vertical stretch, and this plus 9 is going to be up 9. In this case, there was no left or right, and not everything has that, right? So this last one, we have 1/4 multiplied to the x. That means we're going to have what am I writing? A horizontal stretch. And this plus 7 is going to be left 7. Last thing we'll talk about is reflections. And this is where you have negatives either outside of the parentheses or inside the parentheses. If the negatives are outside the parentheses, it means that you have a reflection across the x-axis. If it's inside the parentheses, it's reflected across the y-axis. And I have 5b starred, and we'll talk about that one a little bit more in depth. You'll want to hear that. You'll want to listen because it does directly relate to the 9.2 reflection you have to do on Google Classroom. So let's take a look at this. This has two transformations because we have this negative right here, and it's on the outside. It's going to be reflect across the x-axis. But this 2 also is something we have to talk about. So that 2 is going to be a vertical stretch. Wow. Now let's take a look at 5b. Now as I said, that negative inside the parentheses just indicates that it's going to be reflected across the y-axis. That's the only transformation being done to this one. So I want you to think about this. I didn't, oh man. Okay, I threw a table on there. It's not straight, but it'll work. So the original one, as you know, by now you should be pretty familiar with this. It's going to look like this. Now, if I reflect something across the x-axis, which I will do in green, it's going to be look kind of like this, except not as wonky. And if I'm going to reflect something across the y-axis, I start with my red one because that's my original. And if I reflect it across the y-axis, this point becomes this point, and this point becomes this point. In fact, it ends up just being the exact same figure. So that's the cool part about that. Let's continue on with this. So there's two transformations on this one. The 4 is going to be a vertical stretch, and that negative is going to be reflect across the y-axis. 5D, this negative is going to indicate that it's reflecting across the x-axis. And then that 5 multiplied to that x inside is going to be a horizontal compression. I think my writing stuff is all glitchy. Okay. The last thing I guess that I really want to talk about is vertex form. And I'm just going to throw this out here. I decided we're not going to do too much with vertex form, but this is the form that we've been dealing with when we have an A out here, that's going to be a vertical stretch or compression. This H in here is just identifying the left or right shift, and the K is the vertical, the up or down translation or shift. So this is just identifying that. It's called the vertex form because it easily identifies the vertex. Okay, the vertex is actually H, comma, K. So whatever H is, it goes directly here, and K right here. So if you want to practice these, you sure can. The vertex on this one is going to be 5, 2, and it's reflected across the X, and it's a vertical compression of 1/3. It's moved to the right 5 and up 2. This one has a vertex of -1, 8. Do note that, see, when it's positive, it's negative because this is original formula has a negative in it. So just remember that left, right, that first one, that X indicating horizontal translation is always going to be opposite. As far as transformations, this 4 is indicating a vertical stretch. This is a reflect across the y-axis, left 1, up 8. Reflect across the X, vertical stretch by 5, down 1. The vertex of this one, H, is actually 0 because it's not in parentheses, so it's just 0. It would look like -5 x minus 0 squared plus 1. So the vertex of this one is going to be 0, comma, -1. And lastly, this vertex is going to be 2, comma, -7. And the transformations on that is just right 2, down 7. These are a lot of examples. You should quiz yourself on them, on the ones in the book as well. A lot of these are from the book. I know this is a 17-minute long lesson. I sure hope they don't all take this long. Please contact me. Texting for quickest, email for whenever, and good luck. I will see you next time. Actually, I will talk to you next time.